In Precalculus Lesson 15, we solve rational equations and inequalities beginning with graphical solutions. This is section 3.4 in the college algebra textbook. Let's start by solving the rational equation 8 over x minus 3 equals x plus 4. And I will begin by graphing the left side of this equation, which I'll refer to as f of x, right here. And then I will also graph the right side of the equation, where we will refer to x plus 4 as g of x. Okay, and what we're looking for to solve this equation, we're looking for where f of x equals g of x. And that would be the points of intersection of these two graphs. So here you can see the little black dots are where the two graphs intersect. The problem here is it's a little bit difficult to tell exactly where those points are occurring, so we need a little bit of help from algebra here. So what I'm going to do is I'm going to solve the equation 8 over x minus 3 equals x plus 4 to give us the points of intersection. I'll multiply both sides of this equation by x minus 3 to get 8 equals x plus 4 times x minus 3. Then multiplying x plus 4 times x minus 3, we get x squared plus x minus 12. I want to get a 0 on the left side, so I'll subtract 8 from each side to get 0 equals x squared plus x minus 20. And then factoring the right side gives x plus 5 times x minus 4. So the solutions for this equation come from setting each factor equal to 0. Setting x plus 5 equal to 0 would result in x equals negative 5. Setting x minus 4 equal to 0 results in x equals 4. So I have my two solutions here algebraically, but let's see graphically where I would have found these solutions graphically if I wouldn't have needed a little bit extra help. Well, at x equals 4, I have this point on my graph 4, and the y-coordinate I would actually find from plugging x into either f of x or g of x. Since g of x is a bit easier, we would find the y-coordinate by plugging in 4 for x, and then 4 plus 4 gives a value of 8 for the y-coordinate. So the point 4, 8 is a point of intersection of the two graphs. And then if we look at our x value of negative 5, notice that at x equals negative 5, the two graphs intersect. The y-coordinate there would come from taking negative 5 plus 4 to give us negative 1. So we have our 2 points of intersection. The actual solutions are the x values, and so would be x equals negative 5 and x equals 4. Hopefully that makes sense. Let's go on to solve an inequality. Here we have the rational inequality x minus 2 over x squared minus 16 is greater than 0. And here our function f of x is going to be on the left side of the inequality. We're going to graph f of x equals x minus 2 over x squared minus 16. A couple things to note here are that from what we've learned about graphing rational functions, we would have an x-intercept at the point of when x is equal to 2 here, and so that would be the x-intercept of 2, 0. We would also have vertical asymptotes. By factoring the denominator, I get x minus 4 times x plus 4. That tells me that I'm going to have vertical asymptotes at x equals negative 4 and x equals 4. So just from what we know here from graphing most recently, we would be able to, I think, come up with a solution fairly quickly. We're looking for where f of x is greater than 0, meaning where the graph is above the x-axis, and I have shaded that in red here. So you can see that that would occur from negative 4 up to 2, and we're not looking at where f of x is greater than or equal to 0, simply where it's greater than 0. So we will not be including 2 there. And then we also include the interval from 4 to infinity. So there's our solution, negative 4 to 2, union 4 to infinity. Now let's solve the rational inequality, x plus 1 over x minus 2, less than or equal to 3. And here we've graphed f of x. So the left side of this equation we'll refer to as f of x, and we're looking for where f of x is less than or equal to 3. So I'm going to graph g of x equals 3 here. We're looking for where f of x is less than or equal to g of x. That means where the graph of f of x is either below or intersects with the graph of g of x. So you can see the red shaded area here. Well, I can quickly see that f of x has a vertical asymptote, x equals 2, and that to the left of x equals 2, the graph of f of x is clearly below the graph of g of x. So part of my solution here is going to be negative infinity to negative 2. And then the other part of the solution would start at this point of intersection of the two graphs. This is where it's a little bit hard to tell what that point of intersection is, and we will actually solve this in the next part of the lesson where we do algebraic solutions. And so when we do that, we will find that this point of intersection occurs when x equals 7/2. So the second part of our solution here, the second interval in our solution, would be from 7/2 to infinity. So we have solve the rational inequality with a solution negative infinity to negative 2 union, not including negative 2, and then union 7/2 to infinity, including 7/2. Try on your own number 1. Solve the rational inequality graphically. X plus 3 over x minus 4 equals 2.